Alright, so I'm trying to do problem 5. This is where the car traveling at constant velocity of 15 meters per second passes a cop who's chilling, he's at rest. Cop starts 5 seconds after the car passes, and looks like the cop speeds up at a rate of 3.5 meters per second every second for 7 seconds. And there's actually a question on this one. I forgot to delete it. It says, when and where does the cop catch the car? Okay? So let's check this out. So we're talking about a cop passing a car. Sorry, I said that wrong. We're talking about a car that basically passes a cop that's sitting there, and the car moves for 5 seconds before the cop starts moving at all. So let's just figure out how far ahead this car is. So if the car is going 15 meters per second for 5 seconds, this is just constant velocity motion. So based on this velocity time graph, this area is going to be 15 meters per second times 5 seconds, which should give us 75 meters. So this means before cop starts moving, car, so I'll use the word car for the person who was speeding or whatever, and I'll use the word cop for cop car. So car means the car that passed the cop, and cop means the cop car, okay? So before the cop starts moving, the car travels 75 meters, okay? We'll use that information later. So now let's try to model the cop's motion, okay? I'll do that on the next page. So I'll draw a velocity time graph for the cop, and this graph time starts when car is 75 meters ahead, okay? So that's when we're starting time. And this is a velocity time graph, so this graph doesn't show us positions. But if I were to draw a number line showing this, I'd have the cop at 0, and then at the car is at 75 meters. And this is just a snapshot of what things look like at 0 seconds. The cop's not moving, but this other car, maybe I'll move this down here, that's better. Maybe I move the car, there we go. And then the car is actually already moving 15 meters per second. Okay? So the cop is going to speed up for 7 seconds, it says. And let's draw an acceleration time graph below. Okay? So I'll connect my 7 seconds down here and draw acceleration of the cop. I think it says it's 0.35, right? And the acceleration is measured in meters per second squared. Velocity is meters per second. Time is in seconds. And our acceleration for the cop car starts off constant, and then at 7 seconds, the acceleration is 0. I'm guessing that the cop car can't continue speeding up after 7 seconds. Okay? So let's see what we got here. This area here tells us our change in velocity. So if I multiply those numbers, the 3.5, it's not 0.35, my bad. It's actually 3.5. If I multiply 3.5 times 7, I should get a change in velocity of about 24.5 meter per second, and that's my change in velocity. So if the cop starts at rest, that means this change is 24.5 meters per second, which means the height of this triangle here is got to be 24.5 meters per second. So now I can figure out the displacement for the cop during that 7-second time period, and it comes out to be about 86 meters. We got 85.75 meters. And that's just from 24.5 meters per second times 7 seconds divided by 2. Okay? So now, let's imagine a new problem where at this moment in time, if I look at what I have so far, my cop's at about 86 meters. So I'll write 0, 86 meters. Okay. My car, the car the cop is chasing, is 75 meters plus from 5 to 12 seconds. The 7 seconds that happen after 5 seconds, that's going to be another 15 meters per second times 7 seconds that this car travels. So the 15 times 7 should give us 105 meters. So our car that the cop is chasing is actually at 105 meters at this moment in time. So this is at t equals 7 seconds, right? This would be our picture. So here's the cop car. Here is the car the cop is chasing. And both are moving. The car the cop is chasing is now moving 15 meters per second. That's the speed it was always moving. The cop car is moving slightly faster at about 25 meters per second. Okay? The rest of the problem really isn't that bad. At this point, you could take any approach you want. You could actually, well, we'll just do velocity time graph for the cop. Okay, the cop is going to go 25. Velocity is in meters per second, and time seconds, right? So there's the cop's motion, right? And the car is actually going to go slower, 15 meters per second, t in seconds, right? And let's say at t seconds after 7 seconds, so at time t after 7 seconds, so if we start time over at the 7-second mark, let's find out how much time goes by before they actually meet. Well, the cop is going to travel however far the car travels, plus an additional whatever 105 minus 86 is. So the cop's got to travel 15t plus 86 meters. So the car's velocity is 15t, right? I don't know if I said that right. Let me try to clean it up. So the cop is going to travel 25t, right, plus the 86 meters that he traveled while speeding up, right? The other car the cop is chasing, and in the end, both cars have traveled the same distance if we measure it from where the cop started, right? If this position is where car passed cop, that's also where the cop started, then this is the total of the distance the cop travels from where he started, right? And 15 times t is the distance the car travels in the last chunk of time. And we would need to add to that the 105 meters already traveled by the car. Sorry, not 105, 180. Because we've got 105 meters traveled by the car plus another 75 meters traveled by the car. Again, the car traveled 105 meters in the 7 seconds while the cop was speeding up. So that's 105 while the cop was speeding up. But then, before the cop even started, this car traveled 75 meters. This problem's complicated. But when the dust settles, right, this is the total distance from where cop starts. And this is also, so that's the total distance cop travels. And this here is the total distance car travels. And this is measured from where cop started. Really complicated problem. Anyhow, when you solve this, you're just subtracting 15t from both sides, you get 10t equals, and then 105 plus 75 is like 180. You subtract 86 from both sides of the equation, you get like 94, right? You divide both sides by 10, and you should get time equals 9.4 seconds, right? Now, if you add 7, this is how much time after our 7 seconds. So if we go back to our original graph, right? So in the first 5 seconds, the cop hasn't moved yet. In the next 7 seconds while the cop is speeding up, and then if we add this 9.4 seconds to our 7 seconds, right, that's 16.4 seconds after the cop starts speeding up that the cop catches the car. And then it's actually 21.4 seconds after the car passes